According to the standard representation, quantum entanglement is an invisible connection that exists between two entangled, forgive the tautology, particles. This entanglement means that when the quantum state of one of the particles changes, the quantum state of the other particle also changes immediately. Quantum states include, for example, spin particles. In classical physics, such a concept is simply impossible. For this to occur, for example, one would need to literally connect two particles with a mechanical link. And it is precisely against this backdrop that it is interesting to look at alternative views on the problem. Usually, we literally start from the entanglement of particles. This entanglement either exists from the beginning, or it is achieved under laboratory conditions, or it occurs in some other way. By the way, entanglement itself and the concept of entanglement remain unclear. If you ask how this entanglement occurs, and what it actually is from a physical standpoint, most likely you will receive an answer that these particles literally act like triggers that activate when the state of another particle changes. In fact, we do not have a mechanism or understanding of the nature of entanglement. We do not understand what quantum entanglement is, and this is generally speaking normal by modern standards. Not long ago, I came across a rather interesting article. In this article, everything was essentially based on something else. They did not start from the premise that particles become entangled with each other, but rather from the idea that everything in the universe was already entangled. The fact that we are supposedly extracting some pieces of particles, and that some particles begin to entangle with each other, is actually the opposite effect. It is we who unravel them, in relation to what exists in the universe, and for some time we make them behave as if they are entangled only with each other. You know what? This version seems quite authoritative to me and appears to be quite logical. The thing is, if you analyze the laboratory methods for obtaining entangled particles, sure, there are some misunderstandings regarding what I mentioned a bit earlier, and it's unclear how to measure this if the measuring devices operate roughly like this and need to switch the states of the particles. Alright, let's set that aside and accept that the methodology works a bit differently than I imagine. However, despite all this method of obtaining a pair of entangled particles strongly resembles, so to speak, the identification of an object that is already entangled in advance,